I have a second channel, Cube Comp MTDX. Notice this video is for entertainment and educational purposes only. I am not a licensed heating and air technician. I am just a homeowner who is doing some maintenance on my own system. And I assume zero liability or risk for any damage you do to your system based on any information you get off this video. Now that that's out of the way, let's go get on with the video. Hey everybody. In this video I'm going to be installing and setting up the White Rogers Universal Heat Pump Defrost Control model 47D01U-843. This is a popular option for those who are needing a universal one-size-fits-all replacement defrost control for a heat pump which the defrost port has failed, or in my case, I'm upgrading from time temperature defrost to demand defrost, and this board does that and more. So let's go and have a look inside the box. So I happened to purchase this one off of eBay, so it was new open box. So here's what we have inside the box. We have two temperature probes. We have an outdoor air temperature sensor, an outdoor coil temperature sensor. We have these various stickers that can aid in the installation of this device. We have this sticker which you will attach inside the control cabinet of your heat pump system for future reference to look up fault codes and stuff like that, and to notify any technician who works on your unit in the future that you have installed this defrost control. This is the defrost control itself. Here we have the manual. We have these two wire harnesses. We have this wire here. We have some screws, 4 screws to mount the control. We have some wire nuts and a couple of zip ties. So, just to get you started on this unit, just to give you a little rundown of what it does. So, this control is adaptable. It can do a number of different things. It can operate as a time temperature defrost control. It can operate as a demand defrost control. Not only that, it also offers protections for your heat pump system. It offers brownout protection, short cycle protection. It offers an outdoor thermostat option for your auxiliary heat to limit use of your aux heat when it's not necessary. It also offers the ability to lock out your outdoor unit in case that it's too cold outside and to switch over to backup heat only. This is a very feature-rich board. So installing this on your system, it'll offer you benefits year-round, even during the summer when you're running your air conditioning, because this thing again offers brownout protection, short cycle protection, among other things like that. Stuff that has nothing to do with defrosting or your auxiliary heat. So this can work on a variety of different brands. And of course the box is kind of damaged here, but this thing can replace many different kinds of defrost controls. It works on systems that have the reversing valve energized in cool mode, and it also works on systems that have the reversing valve energized in heat mode, which is read and RUD. So, depending on how your heat pump is wired, wiring this thing into your system will be different. It'll depend on your unit, and I strongly suggest that if you are not familiar with reading and understanding a wiring diagram, I highly suggest that you consult a technician to do this for you. So in a moment we'll go outside and take the cover off the heat pump system and look at the wire diagram. I do have photos already of it, so that way I can study it. We're going to be installing this on a Tempstar heat pump, which is an ICP branded heat pump, which is also known as a Carrier. It's made by Carrier. So we're going to take a look in this manual here. And it gives you a rundown of how this is wired. So in my case, we're going to be setting this up for demand defrost. We're also going to be making use of the outdoor auxiliary heat lockout thermostat. So I'll talk a little bit about that as well. I've already started some of the work inside myself earlier, and just going to give you a rundown of that here shortly. And of course, this is not in the language I'm looking for. Here we are. So, just to give you a little rundown here. There's your wiring table. Now what I'll do is I'll actually put a link in the video description for this manual. That way you can just go ahead and look it up. Because I won't be showing the manual much once we get outside and start working. This is a basic wiring diagram of how this is together. So really, to be honest, this board, as I think I've kind of made clear already, but I'll go ahead and mention again, this board here acts like the gatekeeper of your heat pump system. It acts as a microprocessor control for your entire unit outside. With the protections of this thing built in, your thermostat wiring actually goes into this, and this here will control, for example, the contactor for your compressor and things like that. So if this thing has any sort of faults, such as, let's say, a tripped out low pressure switch or whatever, or let's say you had a power blink and this thing is still in time delay for short cycle protection, this here will prevent your unit from starting up. So again, depending on your unit, you're going to probably doing some rewiring. So I installed one of these on my Goodman system in my single wide I used to live in here. I didn't do a video of that, but anyways, enough to the talk. Let's go and get on to the video. So first things first, we need to go ahead and shut off power to both the air handler as well as the outdoor unit. So we're going to start by switching off the breaker right here for the air handler. Now the air handler is shut off, and that also shuts off the 24 volts AC control voltage for your thermostat wiring as well as your defrost control outside. Okay, so now we're outside at the unit. We're not going to open it up just yet, but we're going to go ahead and shut off power to it. So inside here you have the breaker for your heat pump. Sometimes you just have a disconnect on the side of your house for it. You'll use that or your breaker to shut off power to the unit. Power is shut off, and we'll verify that once we get that opened up. Okay, everybody, so first thing I'm going to do here is after I've got the power shut off to both the air handler and the heat pump, I'm going to go ahead and pop this thermostat off here. It just pops off the wall. Yours may be different. Yeah, the thermostat is off the wall, and you can see our wires up there. So I've already made the needed changes to the thermostat to accommodate the defrost controls auxiliary heat lockout. If we have a look here, you'll see right here is our aux terminal, and right here is our emergency heat terminal. Now previously, this white wire, which is your W for your heat, for your backup heat, that was over here where the brown wire is. The brown wire is an auxiliary, not auxiliary heat, but it's just an auxiliary wire that's usually included with your thermostat wiring, and that can be used for an optional function like this. So the White Rogers defrost control, in order to use the auxiliary heat thermostat, outdoor thermostat, you need to actually wire this brown wire into your aux. In this case, what I did is I moved the W wire, the white wire, over to E for emergency heat. So if I have the thermostat set to backup only, it will get a call straight to the strip heat and bring on the strip heat when needed. Otherwise, the thermostat, when it brings on the auxiliary heat, this will now go out to the defrost control and it will make the final decision as to whether your auxiliary heat should come on or not. Okay, so I was going to talk about the wiring here in the closet where the air handler is. So, right here is the wires coming in from the thermostat. Down here is the wiring coming from the outdoor unit. And over through here is the wire that's going to the air handler. These are all thermostat wiring, and they all have the same wires, and in some cases, certain wires are not used. So, again, coming from your thermostat, you have your red, which is your 24 volts power. You have blue in there somewhere, which is your common. You have your orange, which is your reversing valve on a non-read or on a non-rud or ream system. You have yellow, which is your compressor. You have white, which is your auxiliary heat coil, or your W for your backup heat. Let's see. In case I missed one, I think green is your fan. R is your 24 volts power. The brown over here, that is the new WN signal coming from the thermostat going out to the outdoor unit. So your air handler has 4 wires that are in use. Your G wire, which is your green wire, which is your fan. You have the white, which is the call for strip heat. You have the red, which is your 24 volts AC power. And you have blue, which is common. So your red, your blue. Let's see what else in here. Your white. All 3 devices, the thermostat, the air handler, and the outdoor unit, those are all wired together. Your green wire, only the thermostat and the air handler are wired together. The orange, only the thermostat and the outdoor unit are wired together. In this case, since we're also going to be using the outdoor thermostat. The brown, that extra wire, your thermostat and your outdoor unit are going to be wired together. There's a black wire in there which is not in use. So there's that. And there's also another set of wires down here, which is just where the thermostat wires from the outdoor unit are wired into what was in here. See, this home, this double wide was just moved in here recently, and with that, the outdoor unit had to be pumped down and disconnected from the house to facilitate being moved. And once everything was moved, set back up, the outdoor unit was reinstalled with a new line set. I had one of my buddies who's a tech come out here and take care of all this for me. And down here, everything is wired together, including the brown wire. So we're good to go there. Just if you have any other areas between here and your outdoor unit where let's say your thermostat wires or you have 2 separate thermostat control wires wired together, just check all that. Just make sure they're all wired together. So now going to head outside to the unit. Now on ream and rud systems, I do believe the blue wire is your reversing valve control wire, and that is energized in heating rather than in cooling. And I believe on those systems the black wire may be your common. Look this up online just to be sure, though. This is, like I say, I don't have a ream system, so that doesn't really apply to me. Okay, everybody, so now I got the cover off of the back of this outdoor unit. And what do we have here, guys? What is that? What is that? Man, I'm telling you guys, those car warranty people, they're always trying to get in touch with me, either by phone or by mail, or heck, just leaving random notes everywhere. But anyways, so now that we're in here, let's go ahead and check to make sure that we are indeed dead. We don't have any voltage in here. Although 9.999 times out of 10 you can trust a circuit breaker to be off when it's shown in the off position, but it's always safe to double check to make sure we don't have any voltage in here. Make sure that our power is indeed off. So we'll go down here to the red and black, and we are in fact completely off. Check between ground, red, and ground and black, and we are indeed shut off. So it's gonna be kind of a challenge getting everything on video here. Let me get this note and stick it somewhere else. First thing we need to do is we need to review our wiring diagram. Okay, everybody, so now I've taken a chance to look over the wiring in the unit, and let's go ahead and talk about what we're dealing with here. So right here you have your indoor unit terminal block, which is not the terminal block in there, it's just wired together with wire nuts. The factory wiring you have your common, your yellow. So common is blue, the Y, of course, yellow, that's your compressor coil, your orange for your reversing valve, your W2, which is your auxiliary heat, and your red, which is your 24 volts AC power. That comes into the defrost control. And of course your common also comes out over here on the defrost control. So you have yellow coming in here. It's really just bridged across over here, and out from there is a yellow / pink. It's a yellow wire with a pink stripe on it. Yellow pink is your low pressure switch in this unit, and you have here where it comes out to a discharge temp switch. Now this unit does not have a discharge temp switch, and down here you can see DTS, DTS, discharge temp switch. You can see a little asterisk there. Down here it says maybe factory or field installed. So this unit, I looked at it, it does not have it. The yellow pink wire hooks directly to the blue pink wire. So essentially, the way these units are typically wired from the factory, your Y signal, your compressor coil signal, is wired in series with your low pressure switch and your high pressure switch. These are what's called normally closed switches. So if your pressure is too high and it trips out the high pressure switch, it will open and thus prevent a call from going to the compressor. It's a form of compressor protection. Same as the low pressure switch. If your pressure is too low on that low pressure switch, it will go open, thus not allowing the signal to get to the contactor and energize the compressor. So we're going to be changing that around just a little bit because this board has those protections built in, and the board itself, anytime those sensors, those switches trip, the board will take a log of that, and after 3 trips the board will lock out. Thus it will require you to have a look at the unit, figure out what's going on. Let's say if your fan is not working inside, you're in heat mode and your fan fails, that will cause the high pressure switch to trip. And normally when your pressure would come back down, it would re-energize and just be a repeat cycle over and over and over and over again, which would cause damage to your system eventually. The fact that we have a lockout function there is nice, and also when you go to diagnose your system, you can look up your fault code and recall that fault code for your high pressure switch or your low pressure switch. Let's say if your system's way low on charge, I do believe that would cause your low pressure switch to open. So the yellow pink wire in this case, that'll be going to our low pressure switch leads on the defrost control. The blue pink wires will be going to the high pressure switch on the defrost control. So now that that's said, let's go ahead and head back over to the unit and have a look at what's there. Okay guys, so I'm going to go ahead and start working on this thing. First thing I'm going to do is I'm going to pop this zip tie right here that's holding all these wires together. because we're going to need in here actually. And when I get done, we're going to have some extra wires that are going to need to be tied out of the way. So go ahead and pop that zip tie right there and free up these wires. So this is the factory defrost control on this heat pump. So up here, you can see this is the fan relay. So you have your 240 volts coming off of your contactor up here to this relay, and this comes over to the fan motor. So we're going to go ahead and disconnect those. I need to get some pliers for these because sometimes it's in there pretty good. There it went. So these are the fan wires. Now this defrost control, they give you stickers to put on everything. Now I don't think they have one for fan, but we know this is fan. We'll just twist these out of the way for now. We know that's for the fan. And of course, keep in mind, again, this is something that runs on your main voltage. So just be careful when you're handling that. Of course, that's why we made sure that this thing was dead before we started working in here. Over here is this little pigtail for your high pressure switch and your low pressure switches, where they connect together. Because as I mentioned, right now the way your compressor comes on is you got this Y. You got this you got the Y wire, the yellow wire coming in from thermostat, and it comes out through here to this yellow. I think so. Hang on a second. Yeah, here we are. Y. The yellow pink comes out, goes down to the, I believe it's a low pressure switch, and it comes out to here. And this is where the factory defrost, not defrost, but discharge temp switch would be connected if it were connected. But in this case it's not, so they had these hooked together. So then it goes to your high pressure switch. Might have got this backwards, so get the wiring diagram again just to be sure. So yellow pink is your low pressure switch. Your blue pink is your high pressure switch. So you don't want to get those mixed up. So we'll have to definitely watch that when we go to wire this new defrost control in. So what we're going to go ahead and do is go ahead and disconnect our wires. Actually, before that, so on the defrost control, we have everything labeled. And we have your orange, your red, your W2, your Y, and your common. So I guess before I even get too deep in this, let me tell you how this defrost control actually works. So you heard me mention earlier in the video, I mentioned about time temperature defrost control. Basically what this thing does is it just monitors for compressor runtime and accumulates the runtime based on the selection here, which could be 30, 60, or 90 minutes. It's set to 90. So after 90 minutes of cumulative compressor runtime, it will then check to see if this switch here, this defrost switch, is closed. That's attached to the coil, and if that's closed, it goes into defrost. Now, it doesn't matter whether there's actually frost on the coil or not, and that's pretty much why we're replacing this, because the demand defrost, it monitors your outdoor air temperature in relationship to your outdoor coil temperature, and based upon that, it knows when defrost is necessary. So let's go and get our stickers, and we'll go ahead and start labeling these wires. I'm going to get the defrost control out. I'm sorry I can't get everything on video. I'm in a really tight spot here. So the defrost control you'll see everything here, your CC, your RVS. So CC, I believe, is compressor contactor. And I tell you guys, having to reference two different things at the same time. So really, it's the process of matching up everything in here to what's on your defrost control. I'm trying to explain this the best way I can. So yes, so your CC, your Y out and your CC, that's your Y signal to the contactor. That energizes the compressor as well as the fan, and the fan gets actually energized when this relay closes. This is actually a normally open relay on this board. Maybe not necessarily on your regular defrost board. I may have to go into that later in the video if I remember to do so. So there is how this is wired up. So we'll go ahead and start attaching stickers in relationship to how this board is supposed to be wired up. Okay, so I'm having to extend the brown wire for this thermostat wiring, which is like down there. It was, of course, wrapped around the wire because it was an extra wire that wasn't in use, but now it is in use. Or it will be in use. So what we're having to do is we're having to get this wired in. And it's funny, I tell you guys what sucks about my situation right now is being, well, not living here. All my stuff is, packed up. So I went out to the shed and I happened to see, because I needed some wire, and I happened to see out in my shed I had some elevator panels and elevator buttons that had some spare wire on them. I was like, let me see if there's a brown wire on that, and sure enough, we have a brown wire. So we're going to use this brown wire that was previously used on an elevator button to extend our WN signal from the thermostat, the auxiliary heat signal. We extend that up and get it up to where the new defrost control board is going to be. What I'm doing here is I'm wrapping the wire around, and I'm going to get me a wire nut to secure that into place. Now, some of these wires are going to be as simple as I can just simply plugging them into the new harness, but there's some I'm going to have to wire in. Now I could actually hook up spade terminals on them, but I don't have the stuff to do that. So I'm just going to have to resort to wiring it in, which, I mean, it's alright. I mean, on the low voltage stuff, it'd be fine. But so we'll go ahead and attach this wire nut and get it on there good and secure. This will ensure that our connection is electrically secured. Yeah, I generally put these things on there nice and tight, so make sure it's on there good. And now we have plenty of wire to reach up to the new defrost control board. So off camera, I went ahead and started wiring up all my connections here, and I'll go over those here in a moment. So this here is going to be our WN. Again, our auxiliary heat signal coming in from the thermostat, and the reason why we're doing it this way is the reason why we're utilizing this auxiliary heat lockout is because heat pumps, when let's say it's mild out, like mild, let's say it's cool but mild cool, like 45, 50, 55 degrees, and you're just wanting to knock your chill off in your house and you go to bump up your thermostat or whatever. Normally when your thermostat is not very intelligent, it's just going to go ahead and bring on the auxiliary heat along with the heat pump and waste your electricity. When the heat pump itself is operating efficiently at those temps, you don't need auxiliary heat. I mean, I test ran this thing last week. It was like 58 degrees outside, and it was like 60 degrees in the house. It was just cool in the house. I wanted to knock the chill off and make sure the heat was working. And of course this thing worked perfect. Now my thermostat does happen to be configured to where it doesn't automatically bring on the auxiliary heat. It tries to use just a heat pump for a little bit first. But many thermostats, like what was in my single wide, no. It would, first thing it would do is try to bring on the strip heat. So now let's go ahead and go over our wires. So we got our WN, which I just attached the sticker to. This is our auxiliary heat coming in, auxiliary heat signal coming in to the defrost control board. So we'll go over thermostat wires first. We have our W coming from the thermostat to the defrost control. That's your compressor. That's your compressor call signal. This comes on in heating or cooling. You have your common, which is of course your common wire. You have your W, so this will be the W out on the new defrost control. This is what the defrost control uses to bring on the auxiliary heat, the heat strips, when the defrost board is in a defrost cycle, or when it's below the set point temperature, the lockout temperature. When it's below that, and your thermostat calls for auxiliary heat, and it's cool outside, and it's below the set point, it will also energize this signal. You have your red, which is your 24 volts power coming in. You have your orange, which is this is coming in from the thermostat. This is energized in cooling mode on this unit, and the defrost control will energize this for cooling, and also energize it when it goes into a defrost cycle. You have two of these compressor contactor wires. These go from the defrost control board to the compressor contactor to energize it when it wants to bring on the compressor. You have these two RVS reversing valve leads. These go to the reversing valve. This way, when the thermostat is calling for cooling, these will be energized at all times. The thermostat has the cooling switch enabled. Like I say, your thermostat is set to cool. This will be enabled even when the unit's not running. And the defrost control again will energize your reversing valve to bring on cooling mode to initiate a defrost cycle. You have your LPC, which is your low pressure switch. Right here. And you have your HPC, your high pressure switch. Now, use of these two on your new defrost control is not required, although I'd say it's recommended. That way you have better diagnostics. And of course, as I think I mentioned earlier, if there's a problem with your unit that would cause your high pressure switch or your low pressure switch to repeatedly trip, this control will lock it out to stop it from damaging your unit. And over here you have your fan leads that go. These are the mains voltage leads that plug into the fan relay that's on the defrost control board. So now that everything is wired up and ready to go, we're going to go ahead and disconnect and prep our harnesses. So this is your thermostat wires coming in. These, and of course, this too, your WN. These will get wired into one of the two wire harnesses. This is the thermostat wiring harness that comes with this defrost control. We'll be wiring these in. So all of these, it looks like all of these will have to be wired, stripped and wired in. And you have a second wire harness that plugs into this new defrost control. Here we have your compressor contactor leads. your high pressure switch leads, your low pressure switch leads, and your reversing valve leads. So we're going to start with the thermostat leads, get those all ready to go. And I got a wire stripper over here. I like this wire stripper here because it's easy, and it's easy on delicate wires. The wire strippers they now sell at Walmart have like a different design where the top is like this, kinda, and it'll eat up and just tear up like delicate thin wiring. I do have one of those, and I did use it when I was working on like wiring inside the house, electrical wiring, that kind of stuff. But other than that, for small stuff like this, I always like to use this one here. I got this off of Amazon. Don't think I paid no more than 10 or 15 bucks for it. But so now we got to go ahead and cut the you gotta cut the wiring on the original harness. I'm gonna cut it back just a little bit. Should I ever have to put this original board back in, which I don't think I will. Should I ever have to do it, I'm going to cut it back to where it could be wired back in. Although if something was to go wrong with this defrost, the new defrost control, down the road I would probably just replace it with another one just like it. So we're going to cut all these wires just a little ways back. Again, make sure they're all labeled, and they are. Alright, now what we got to do is we got to strip the wiring. I'll cut this one back just a little bit. No, of course, yeah, this is our WN. That wasn't part of the original wiring on this unit. And these stickers, the only thing I don't like about them is they keep wanting to back off. So let's go and get this thing, get the wiring ready, and then we'll change out the actual control. So we'll go ahead and strip our wiring on each of these. Now we'll take our thermostat wiring harness and we'll do the same. For each of these. We'll do it just past where the stickers are. It's better, it's for easier reference. Now, chances are we're going to need additional wire nuts. I got some extra ones in the house. They would work for this, so I have to pull these stickers back a little bit. The good thing is all the wires coming in from the thermostat, they all correspond with the wires going into this defrost control, so the stickers here aren't really necessary. So I'm actually going to, let's see here. I'm actually going to take those off probably, unless I'm able to strip off enough wire while leaving them there. Yeah, we're going to take these off. It would have been nice had White Rogers or Emerson put these stickers down a little further back. So I guess that would be kind of a gripe I have about this kit. There's only one other complaint I'd have. Not really a complaint, just kind of a dislike, and I'll talk about that later in the video. Alright, so the camera stopped recording while I was working on this. So what I'm doing is I'm having to splice in the wires from the thermostat to the thermostat wire harness for this new defrost control, because these incoming wires do not have spade leads. They were just plugged into a factory harness on this defrost control board. So right now I'm just in the process of getting these wired in. Okay, so the wire nuts that come with this kit are rather small, so I got some larger ones in the house I'm going to grab to wire nut these together. Alright, so I got some bigger wire nuts for these wires. I think it's a more appropriate size here. Get them on there really good. The last thing you want is for these to come open and possibly ground something out. I'm also going to wrap these in electrical tape. I have to go back inside to get the tape, but wrap the ends of these electrical tape to try to keep them sealed a little better. So the Goodman unit I did about 4 years ago. Most of everything in it was all spade terminals, so I pretty much was able to just plug everything in, even the thermostat wires. A lot of defrost boards are that way, but some like this are not. They like this one here has its own special plug-in lead. Yeah, so just went and got my electrical tape. Just had a couple, had a family stop by on the road out here in the car. Curious if the place is going to be for rent. You'd be amazed the amount of people who have stopped and asked about this place since this new house was moved on. I'm not kidding you guys. The day that the front half was moved on, that afternoon, I mean, the front half was still on wheels and was still sitting on a tractor. And people were already stopping. Had a couple of people stopping. One guy who lives back there stopped and took pictures, which I mean, I guess is all right, but there's a lot of interest in this place. I mean, this new home really added a whole lot of curb appeal to this property. But if you're curious about the home itself, feel free to go over to CubeCompMDDX, where I'm posting update videos on the home. Sticker off my finger. Yeah, like I say, feel free to go over to CubeCompMDDX, and if you're interested in updates on home, I've been posting videos all throughout the summer. Well, ever since this project got started back in April. It's been that long, and I tell you guys, I'm so ready to be done with this place and moved in. You just have no idea. You know what's crazy is looking back at this, I probably could have pulled this thermostat wire through some more and had enough wire to just wire straight from this thermostat connection to here, but oh well, that's all right, no big deal. You can plug it in right up in this area right here. That's about where it's going to go. So now we'll go ahead and focus on the wiring for the pressure switches, the contactor, and the reversing valve. So one thing I'll do is I'll probably get some more wire nuts. Not wire nuts, but zip ties. Maybe not. I don't know. We'll see. To try to tidy these wires up some. Don't exactly want to leave a total rat's nest in there. These things are typically always a rat's nest. And going to unplug this right here. So that's pretty much all we need off the defrost control board. Okay everybody, so now we have both the internal wiring and the thermostat wiring wired into the connectors for the new defrost control. So now all we like to do is we got to track down exactly where this defrost temp switch goes. So we can change it out for the cool temperature sensor. It goes up inside here. And it goes over to this section back here. So that means we're going to have to take a little bit more off of here to get to it. Okay everybody, so I got the fan off, or out of the way, and right inside here, you see that right there? That is the defrost temp switch. Look at where it's located. Yeah guys, ain't that ridiculous? So essentially it's behind this panel here, which is this whole big thing that goes from here around the back here. So with all these refrigerant lines and stuff going going through it and everything, well, I mean, it could be taken off because they do have recesses there, but again, you got to take all of this off here. You got to take this whole piece of sheet metal that has the defrost control, the cap, the contactor, all that mess. You got to take that off, or take the fan off and set it to the side and get in here this way. Since I got this off, I'll go ahead and try to get some of these old leaves and stuff out here too while I'm in here. But that's just ridiculous, guys. So I'm gonna have to cut this zip tie right here, or I may just cut the wires to the defrost temp switch. That way I ain't gotta bust that zip tie, and I'll get this changed out. Okay guys, so I got the fan back on. The new sensor is in there. The old one was such a pain in the butt to get out that I just snipped the wires to it right next to where the sensor is, and I clamped the new sensor right next to where the old one is on the same line. The manual does tell you to locate the outdoor cool temp sensor as close as possible to the factory sensor location, so that's what I did. I'm telling you guys, it's crazy. Carrie, you should be ashamed of yourself. You have to make a repairman have to take the fan off, or you have to make them take all the stuff off to get this off to get to the defrost sensor. So I placed a new one in a location where I can pull the fan off to get at it, to pull it off. So now we have the outdoor cool temp sensor. And oh, by the way, guys, so I'll put the fan back on. I had to make sure it was lined up just perfect because there is not much room for error in here. It's kind of hard to see, but there is about a ½ centimeter of clearance between the edge of the fan blade and the unit. So, fan's back on. Cool temp sensor is now on. Now the outdoor air temp sensor, that's a little different. Literally just this right here literally just hangs out inside here in this area. So now I'm going to get the camera back on a tripod and get this installed before we lose our sunlight. Okay guys, so now we're going to go ahead and take off the old defrost control board and replace it with our new one. Since we got everything else pretty much taken care of. Okay guys, finally found the right socket as a 1/4 inch on this thing. Yeah, it's pretty long. It slides out like that. So, the new defrost control, it has this plastic bracket behind it. The idea is that way you can install it however you like. I'm going to install, I think I'm going to mount it just like this. And the thing is, it comes with self-tapping screws, because most likely you're going to have to tap new screws or new holes when mounting this bad boy. So what we're going to do is orient it like this. You can do it however you like, actually. When you go into setup, the first thing you'll get to do is you can select DO from the options for display orientation, and you can orient the display however you want it. We're getting up against something. Yeah, we're just going to use a smaller screw. Find a little bag that came with this thing. I tell you what, guys, that cool temp sensor, having to take the whole fan off just to get at, really messed with me. Really messed with my timing. So, see if these small screws will thread okay. Oh yeah, not a problem. Alright, one moment guys, I gotta see what that text message was. I got a roofer coming to look at my roof today, or supposedly. Okay, so I'm going to mount this like I mentioned. I'm going to use this initial screw just to kind of get it started, because I want to make sure that all the wire leads will reach it. I think they will. Get this one tightened in. Alright, so the ones I was, I guess, mostly concerned about were the fan leads. And let's see, if they don't reach, I may have to put this board in a little different spot, and they'll reach. We're good there. All right, so now we're going to have to use these self-tapping screws to get this thing in there. I think I gotta watch for it to make sure we don't get metal shavings on that board. Alright. That should be enough to keep it in place. I ain't gonna worry about the rest of it. I mean, obviously it ain't going anywhere, so. Alright, now it's a matter of plugging everything back in. So, we got our thermostat wiring here. That goes right there. Simple as that. We got our fan wires. It don't matter. Don't really matter which way you plug them in, as long as you plug them in. You gotta have your fan. So, get this other fan wire, get it up here. That's plugged in. What I don't like about these spade terminals is sometimes they tend to open up and don't get as good as a connection as I'd like to see. You know, especially hate it when they use these in like electric furnaces and stuff, or heat strips. I mean, those things, you know, single heat strip pulls, how about, let's say a 10 kW pulls, what, like 40 something amps? Burn your wires up over time. Now this fan don't pull anywhere near that much, but we do want to make sure it's in there good, and the other one's in there fine. So now we'll go ahead and plug in our outdoor cool temp sensor. That goes right there. The outdoor air temp sensor, I'll plug that in last because I'm gonna have to tidy up the wires, and I'll place it in here somewhere. I don't want it like just laying in the thing. I want it to be like kind of tied up. So now we got our internal wiring, like the reversing valve, the pressure sensors, or your pressure switches, a compressor contactor, all that good stuff. Again, while we're at, just making sure that everything is good and secured. All right. I tell you, the only thing I don't like about installing one of these is the rat's nest you get with your wires. It's like a computer case management. This is kind of similar. So I'm gonna bundle up, try to get everything bundled up here. My idea here is to have two sets of bundled wires, and as I mentioned earlier, I'm going to pull this out of here. And I hear somebody down the street is blasting some copyrighted music, so hopefully that doesn't interfere with my YouTube video here. anyways, let's get this in here. That's why I'm kind of talking, to try to try to get that out of the video. Just gonna try to reuse this zip tie here. You know what? I'm gonna take that out. I got 2 new ones in the kit here. Let's go ahead and use them. I tell you what, guys, with YouTube, how they are with copyright and stuff, it's just crazy. When it comes to music, I've heard that they've changed things where it's not as bad as it once was. But literally, you could be like shooting a video, walking down the street, and somebody in a car drives by with the radio blasting something off the radio, and you get a copyright claim. You lose monetization on your entire video, and the copyright claimant gets to make money off of that little few seconds of their content being played by somebody else. Like I say, I think YouTube has made some adjustments to that, but yeah, it's crazy. Let me finish this up and I'll resume the video. Okay, guys, so I got everything wired up. Got the outdoor outdoor cold temp sensors inside, but I got the outdoor air temp sensor right here. It's just tied in with these wires right there, and the sensor's just right there in the middle. The idea is we don't want it to have any like influence from air coming through the system, because obviously air inside here is going to be colder when it's in heating mode. So now what we're going to do is I'm going to just double check everything one more time before we actually fire this thing up. Particularly the thermostat wiring. Someone's dog wearer is making a perfect bark or perfect howl because it is Halloween. Doing this on Halloween. Yeah, we got 30s in the forecast later this week, and I want to get this defrost board in. So, all right. So we're not going to be switching this breaker on this yet. We're going to be going inside. I'm going to go inside and switch on the breaker to the air handler, which will power up this defrost board. That way we can program it. Okay, everybody. So now I have the air handler breaker switched back on. That means the air handler is supplying 24 volts AC to the thermostat and this defrost control. You may be able to see there's a little happy face on it. That's a good sign. That means it's seeing the high pressure sensor. It's seeing the low pressure sensor both closed. It's seeing, probably seeing no issues with the temp sensors. Now, if you elected to not hook up the high pressure and low pressure sensor leads to this, instead you have them wired in series with your yellow, you need to have them done either that way or have them wired to this. Do not have those two sensors just like dang loose and not hooked to anything, because you will damage your unit in the event, let's say your fan out here fails or your blower fails or something like that happens, or you run low on charge. I mean, so if you elected to go with the route of not hooking your high pressure and low pressure sensors into this, you will have two fault errors. But in this case, we did in fact hook up the high pressure and low pressure sensors. We had the smiley face, and it's happy. So you can see the smiley face is sideways. So essentially, to set this up, you have two buttons on the side of this. You have an option and a select. So we're going to press option. I have to press and hold. You see we have DO. We'll hit select. You have to press and hold it. Now you see we have high. High is sideways right now. We've got to press, 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 and now it's displayed in the right direction, so we'll press Option. Alright guys, so I had a roofer just stop by to give me an estimate, and of course now it's almost completely dark, so we're working in the dark now. Yay! So now we'll go ahead and run through the option setup on this thing. So press and hold Option. You get DO for display orientation, ER for error recall, FR for fault recall, OE, this is the quick OEM setup. You can use that to, based on this chart here, there's a reference that you can just reference your OEM and do a quick setup that way with default options. But we're going to do everything manual. So defrost, by default that's set to demand. Actually, I already did go through some setup here, then the camera quit, and then of course the roofer showed up, so I'm doing this over again. So hit select. We're on demand defrost. We'll leave it there, so we'll press Option. Press Option again. So ET, that will be enabled temperature. The default was 35. I've set it to 32. Now the carrier default is 30, but I'm go with 32. Since that's freezing. So press and hold Option again. Press Option again. So termination time, TT, or excuse me, termination temperature. 70 degrees is the default. I set this in a 65, which is the carrier default. Anyways, we'll press Option again. Now we have SS, capital SS, so short cycle time. That is the minimum time between the time this thing shuts off and the time it'll start back up. The default is 5 minutes. We'll leave it set to 5. So we'll press Option to go back, press Option again. So R, this is reversing valve. So the default on this is orange. So as long as your heat pump is not a reed, excuse me, a ream or a rud, which uses the blue wire, you can see it's set to orange. As long as you don't have a ream or a rud, you leave it to orange. So press Option again. Press Option again. So SD, reversing valve shift delay time. This option is, so when this thing goes into defrost, a lot of times when the heat pump shifts into defrost, the compressor makes a bunch of racket. You can go in here and set a time delay in seconds, which the default is 30. We're going to leave it for this one. Now, my old Goodman heat pump, it had a reciprocating compressor in it. I'm not sure how it would have done with that. And besides, the Goodman was a rare kind. It was one that didn't make a bunch of noise when shifting in and out of defrost. So I'll actually set that to 0, so it will just remain running. So this one's going to shut off for 30 seconds, and then it'll shut off, shift the reversing valve, and then 30 seconds later it'll turn the compressor back on. So DT, that's defrost time, maximum defrost time. The default is 14 minutes. Now carrier has a max of 10 minutes. And most of these have 10 minutes, really. Carrier does, Goodman does. So we're going to set that to 10. Now, let's see here. Now, if you find that this thing is, like, let's see if you find this thing is getting ice buildup and it's not able to get it off in a defrost cycle. I mean, it could be your max temperature is not high enough, or it could be some other parameters in your setup. So we're going to go back to, all right, so HL, auxiliary heat lockout. So the default is off. However, we do have this set up to lock out auxiliary heat above a certain temperature. So we're going to set that temperature to, let's see here, set that to 40 degrees. It's crazy this thing goes all the way down to 0. That's kind of crazy. So 40 degrees. So essentially, if the thermostat inside the house tries to bring on the auxiliary heat and it's like 45 or 50 degrees outside, it ain't happening. save your electric bill. Because again, I think as I mentioned earlier in the video, heat pumps, when it's mild, when it's not super cold out, their coefficient of performance is really good. They can do a lot on this on their own. So, all right, so LT, low temp compressor cutout. By default, that's off. However, I'm going to set this to 0. Even though we've never gotten to 0 degrees here in my lifetime, we've gotten close. So we got down to like 6 degrees, I think, in 2018. But I'm going to set this to 0. It goes all the way down to -10, by the way. So 0. Hit press option to save that. Press option again. RT. So brownout random time start delay. We'll leave that set to on if it's on. There we are. So basically, when your power comes back on, I think what that means is it, in addition to the 5 minutes, or it has a little bit of random time. It helps with your helps your power company with demand when restoring service. So low pressure switch, we leave that turned on because we do have the low pressure and high pressure switches wired up to this. Again, they need to be either wired up to this control or they need to be in series with your yellow circuit. They do need to be in use. High pressure, same thing. On, okay. So if you didn't have your 2 sensors wired into this and you had them in your Y signal, you would have turned both of those off. Otherwise you would get the codes. The errors in your system would not start. Alright, so BO. This is 24 volt brownout protection. We're going to have that set to on, which I believe is a default. Alright. So press option again to save. Press and hold to save. And we're done. So you can see the little happy face now. So we're going to do a quick little test of this unit. Now, if it were colder outside, we'd probably do a test defrost. But since it's not super cold out, I'm going to start this thing in cooling. All right, that's before I energize this thing with 240. Let's just make sure nothing. Let's see, make sure your fan leads are good. Oh, that's good. All right, we're going to go ahead and energize this thing. So go ahead and start this unit up. Really start the breaker up. I'll go inside and give it a call for cooling. As you can see, we have a C there for cooling. This unit is now running in cooling. So, go back inside and shut it off because it's not very hot out here. So, I'm going to shut this off, wait 5 minutes, I'm going to try it in heat mode. Okay, everybody, I think it's been about 5 minutes now, so I'm going to go ahead and put in a call for heat. And we test the cool first to verify that the orange signal from the thermostat is getting to the board and the board can energize the reversing valve. So now we're going to start up in heat, which should just be just as simple. Just energize the compressor and the fan, and you have it. Okay, so now we're running in heat mode. The air coming out of the top of the unit is cold. So when it gets cold enough outside, this thing's probably going to defrost by itself to start calibrating itself. So the cool, they get down to 32 degrees first for that to happen. Okay guys, so since we're out here and this thing's been running for a little bit, I'm going to actually go ahead and do a test defrost cycle. So we're going to initiate a test defrost cycle. We're pressing hold option select until the T comes up, and then let go and see what happens here. It's going to bring on the auxiliary heat. The auxiliary heat is running. So it stayed in defrost for just a second because it's not really cold out here. I think that's why it exited so quickly. So really it's just to show you that it's working, that it can shift into cooling, turn off the fan, start up the strip heat, that kind of stuff. So that tells us that the defrost function is working. So now we can go ahead and shut this off and go ahead and put the cover back on the side, and we're done. Okay everybody, so the last video footage you've seen in this video was shot back in, I think, late October 2021. Here I am shooting this video in February 2022. So I've had to do a couple of tweaks here and there to get things working like they're supposed to. But overall, I'm definitely satisfied with that defrost control. So let me go and talk about what I had to do here. So the biggest issue I had was, well, for one, since this defrost control bolt was off of eBay, the seller kind of told a lie about everything being brand new. The defrost board was brand new, the wiring harness was brand new, but the sensors were not brand new. Basically, he bought the kit off of Amazon or somewhere, and apparently he bought it just for the two thermistors, the outdoor cool temp sensor and the outdoor air temp sensor, because apparently his were bad. So here's the issues I had. The cool temp sensor that came with the kit was obviously used, and it was reading out of spec. This would cause the unit to not completely thaw itself, frost, when it would initiate defrost, and it would just typically it would take forever to initiate a defrost cycle. So let me go ahead and show you where the sensor used to be placed. And of course got the neighbor's yappy dogs going right now. So right there where that OEM defrost switch is, that's where I initially had placed the cool temp sensor in the previous video clips. But what was happening there is the unit would trigger defrost way too early. Matter of fact, it would typically trigger defrost after about 30 minutes of accumulated runtime since the previous defrost. That's, I believe, when the demand defrost logic begins analyzing the delta T between the air temp and the cool temp. And because that little spot right there where the OEM switch is placed, that spot was getting much colder than the actual coil, it was tricking the thing into going into defrost when it didn't need it. It would pop into defrost, and it would exit defrost after like a minute and a half, if even that. It'd be the equivalent of, let's say, a dry defrost on an interval or time temp defrost setup. I then placed the sensor down one rung, and this is, mind you, this was with the sensor I got in the kit. Place it down there, and it would allow frost to build up pretty heavily, but it would not, when it would go into defrost, a lot of times it wouldn't, the part of the coil would remain frozen over. It wouldn't completely thaw at the coil, even with the termination temp set that's like 75 degrees. So I suspected that the sensor was faulty. So I ordered a pair of sensors on Amazon, 10K ohm NTC thermistors. So here's what one looks like. Zoom out, sorry about that. Right back there is one of them. There's 2 in a kit. Got these off Amazon for a whopping $10 each. I think you're seeing it. Yeah, right there. That is one of the 2 sensors. That's the air temp sensor. I ended up replacing them both. But the coil temp sensor, definitely something was off with it. Because after I replaced the sensor, and I kept, mind you, I kept that sensor in the same spot, 1 rung below the OEM placement where the defrost switch is. Yeah, there we are, right there. Just 1 rung below that. What would happen is it would still freeze up pretty good, but then it would initiate defrost and completely thaw the coil out. But it would still allow this thing to frost up pretty heavily. It was to the point that the unit was no longer operating efficiently, and as a matter of fact, I think a couple of times the auxiliary heat was even kicking on, trying to help the system keep up. Because when you get that frost buildup like that real heavily, it really affects the efficiency of this thing. It can't extract heat out of the air because, well, the coil's froze over. So what I did is I ended up placing the coil temp sensor right there. Maybe you'll see it. Sorry, it's blurry. I'm trying to get this through the fan here. So right there is where the coil sensor is. Now it's blurry. It's basically 1 rung below that spider that comes off the liquid line. I think it's a liquid line. And that's the spot where the coil seems to freeze up a bit more. For some reason, this unit tends to frost up the top half of the coil a little heavier. Now, I don't think the charge is off because it heats the house just fine, and it cooled just fine last year. And it defrosts. It's pretty effective at defrosting. So this system, by the way, it came with this home, and in order to get it here, my HVAC buddy had to pump this unit down and split it off of the house. And when we got it here, ran a new line set, and he ran nitrogen through the line set and through the intercoil, evacuated the system down after brazing up the new line set, and he just opened the valve and let the contents of the refrigerant back into the system. And from what he was able to determine, it was okay on charge. So, I mean, there you have it. So, again, I placed the coil temp sensor right there. You may be able to see it. There we are. Just up 1 set of rungs on the on that coil, and that seems to have gotten this thing working like it's supposed to. It took some trial and error, guys. We had a winter storm back in January, and of course with the freezing rain and the sleet and the snow, the dew point was way up there, so this thing was freezing up quickly. And I knew something wasn't quite right because I could reach around there and grab that sensor, the air temp sensor, and it would kick this thing to defrost. And once it went into defrost, it would completely thaw the coil out. So that afternoon during the sleet, getting pelted on by sleet, come out here and I moved that coil sensor up 1 rung or 1 set of rungs, and now it works like it's supposed to. Definitely happy with it. There are a couple of faults though with this board. I'm going to talk about those inside, or not exactly faults, just things I don't exactly like about it. Okay, so here's the box that the defrost control came in. This is show the product, even though it's kind of, well. So I just showed you the kind of the issues I had and how I resolved them. That's one thing about these demand defrost boards is you kind of have to play around with things like in regards to sensor placement and stuff like that. So I'm shooting the rest of this video here because I got some let's see, dump and bake meatball casserole finishing up in the oven. So anyways, so there's the old defrost board. It's a very typical carrier board you find in ICP heat pumps. Time, temperature, defrost, garbage. So here's one issue I have with this demand defrost control, or this the 47D01U-843, is this relay right here that controls power to the fan. On most defrost boards like this one here, this relay is normally closed. The only time it opens is when it's energized. Let's say the unit goes into defrost. On the flip side, the relay on this board is normally open. So in order for the fan on your unit to come on, this relay must energize. So instead of energizing and switching the relay only when there's a defrost necessary, it's the opposite way around. This relay now has to activate to turn the fan on. So anytime the unit shuts on, or it comes on and shuts off, and heating or cooling, this relay has to energize. So this relay is getting worked a lot more because of this. So, I mean, there's a chance that relay could have a higher chance of failure because this relay is normally open and it has to energize to close. The reason why they set this up this way is by design, this board delays the fan by about a second. So when you get a call for heat or cooling, or it comes out of defrost and the contactor closes, it waits about a second before it energizes this relay. It's the reason why they do that is to lessen the amount of demand when the unit starts up. I mean, it's a smart idea. It's a very smart idea, but I think because of this, you could have problems with that relay because it's being worked a lot more than, let's say, if this were a normally closed relay, which would only energize and open the circuit when there's a call for defrost. Another issue I have with it is, see, this board offers the functionality similar to I think what's called Smart Shift by Goodman, and I think a couple other brands do it as well. When those OEM defrost boards go into defrost, they shut off the compressor for like 30 seconds or so, which allows pressures to equalize without the compressor making a whole bunch of rack, and this applies mainly, I think, with scroll compressors. In other words, this functionality really, I think, only should be used with scroll compressors, if I'm not mistaken. But on those OEM boards, when they initiate defrost, they shut off the contactor to the compressor at the exact same time that the reversing valve is energized to shift it back into cooling. So, therefore, you don't really get any compressor noise. But with this board, however, when a defrost comes, it energizes the reversing valve and then waits a second before it de-energizes the contactor. So the compressor shuts off right as the reversing valve has already shifted and pressure is starting to equalize. So it causes for the compressor to make a bunch of, well, it's not as bad as it's not as bad of a noise as it would be if I had the functionality completely turned off. In other words, the compressor remained energized during a reversing valve shift. But I don't like the fact that this board energizes the reversing valve and waits a second before de-energizing the fan. And I should mention that when it shifts back from defrost into heat, when it shifts back from cooling to heat, it does the same thing. It shifts the reversing valve. In this case, it would de-energize the reversing valve, wait 1 second, then shut off the compressor. So you actually get a bit of a wind down noise from the scroll compressor. And I've researched online, and it's not an issue that will affect the reliability of the compressor, but still, it's something that I think Emerson really needs to address. Another issue is the fact that you cannot custom set a delta T on this product. It sort of self-calibrates. So, as you've seen outside, I was talking about how I had to relocate the sensor several times. That was to try to get the sensor into a spot that this board's programmed delta T was acceptable with. In other words, the delta T is the delta or difference between the outdoor air temp and outdoor cold temp sensors. That's how demand defrost works. It looks at the two and it compares them, and when there's a certain amount of gap, it triggers defrost. So really, this board should have an auto function to function like it does, but it should also allow you to set it should allow you to manually set a delta T. Another thing I like to see is I would like to see the ability of this product to read out the temperatures of its sensors, which will be very nice for diagnostics. It's considering it does, and you can't see here because the box is messed up, it does have the capability of displaying 2 digits. That's how you can set the parameters, such as the times and the temperatures on it. Stuff like, for example, the termination temperature or the enable temperature, stuff like that. It does have the functionality of being able to display 2 digits. So, okay, why can it not show you the values that it's interpreting from the thermistors for temperatures? This would be really great for diagnostics. So if you're suspecting there's something wrong with the thermistor, normally you would have to disconnect that thermistor and pull out your own meter and reference a chart to do a compare, just to sort of see what the thermistor is reading in resistance and compare that to the temperature that correlates with. Whereas if this board had the functionality to where it would display the temperature, it would be nice to have. So I want to say that's about everything I need to cover with this product. Again, this is not something that you should be messing around with or installing if you don't know what you're doing. If you aren't sure about stuff like this, it's definitely good to have a heat and air technician do this for you. I just so happen to know a good bit about heat pumps and how they work and how these defrost controls work, and that's why I was able to complete the installation myself. This will be the second one I've installed. The last one installed was on the 2007 Goodman unit that was on my single wide I used to have, and I'm guessing that unit is still in service. So, I mean, anyways, guys, so that wraps up my installation and sort of review of this product. Hope you enjoyed this video. Thanks for watching. Well, everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up, but if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.